Good morning, students. Today I'm going to take nuclear reactions. Okay, students. In last class we discussed nuclear fission reaction. Reaction, fission reaction, right? So today we are going to discuss about nuclear reactions. In that nuclear reactions, chain reactions, and nuclear fusion. Okay, students. Right. First one is chain reaction. Okay, students, we last class discussed nuclear fission. Right. What is nuclear fission? Heavier nucleus split up into two small parts. Okay, that is two fragments. That is called nuclear fission. Now come to the chain reaction. What is chain reaction? See this. Uranium nucleus, that is 235, when bombarded with a neutron. Uranium nucleus, when bombarded with a neutron, undergoes fission producing three neutrons. So please remember, in fission process neutrons are produced, no, one neutrons. Okay, so that one here, neutron bombarded with uranium will produce how many neutrons? Three neutrons. Uranium nucleus bombarded with neutron produce three neutrons. Okay, so these three neutrons in turn can cause fission in three other uranium nuclei present in the sample, so thus producing nine neutrons. So three neutrons again to interact with uranium to produce another three s neutrons. So totally now 9 neutrons. So these 9 neutrons in turn may produce 27 neutrons and so on. So again that 9 neutrons interact with uranium nuclei and produce again another 9 neutrons. So 27 neutrons. So this is known as chain reaction. Which one? Chain reaction. Okay, right. A chain reaction is a self-propagating process. Which process? Self-propagating process in which the number of neutrons goes on multiplying rapidly, almost in a geometrical progression. So the chain reaction is a self-propagating process, that is automatically selfly produce. Number of neutrons goes on multiplying. So three neutrons again three, so again three, so three into three. So it will be continuously yes goes on. So this process nothing but chain reaction. Okay, students, which reaction? Chain reaction. Okay. Now, there are two kinds of chain reactions. One is controlled chain reaction, another one is uncontrolled chain reactions. So, the chain reaction classified into these two types. One is controlled chain reaction, another one is uncontrolled chain reaction. Okay, students? Right. And first one is controlled chain reaction. What is controlled chain reaction? See, we can control the reaction, nuclear reaction basically, yes, in a sustained manner. So that is the controlled chain reaction. Okay, students, say this. If the controlled chain reaction, the number of neutrons released is maintained to be 1. So finally the number of neutrons released in reaction to be maintained 1. So will be maintained only one neutron. Okay. So that is the controlled chain reaction. And this is achieved by absorbing the extra neutrons with the neutron absorber, leaving only one neutron to produce further fission reaction. Because of further fission reaction is for further reaction, one neutron is available, or one neutron is enough to initiate the further chain reaction. So that's why, so with the help of neutron observers, we can achieve this. Okay, right. And the reaction is sustained in a controlled manner. The nuclear reaction is sustained in a controlled manner, so we can control that reaction. Okay, and the energy released due to the controlled chain reaction can be utilized for constructive purposes. And the controlled chain reaction is used in nuclear reactor to produce energy in sustained and controlled manner. So if we go to the nuclear reactor, it will produce electricity, right? So for electricity purpose, we are using what? So in nuclear, the nuclear power plant produce the electricity, right? So with the help of which one? Nuclear reactions. So in that nuclear reaction, controlled chain reaction takes place. So in that nuclear is station in nuclear core having uranium, and yes, and the one neutron is bombarded with uranium, produce a chain reaction. So that chain reaction to be controlled is by the various electronic circuits. Okay, so the chain reaction to be controlled with the help of robots and humans also. Okay, so that's why the chain reaction takes place in a controlled manner. Okay, so in nuclear power plant, inside that core, chain reactions, controlled chain reactions takes place. Okay, okay, the core of that nuclear power plant is uranium pellets. That means n number of pellets means a small amount of uranium filled with tubes. So that is called as pellets, uranium. So small amount of uranium is enough to is produce the large amount of energy. Okay, students. Okay, so for generating electricity is, we are using what? So we are initiating the nuclear chain reactions, controlled chain reactions. Okay, right. Next, uncontrolled chain reaction. Which one? Uncontrolled chain reactions. So what is uncontrolled chain reactions? We can't the we can't control their reactions. That is the uncontrolled chain reaction. Okay, see this. In the uncontrolled chain reaction, the number of neutrons multiplies indefinitely and causes fission in a large amount of fissile material, and this result in the release of huge amount of energy within a fraction of second. So it is that the chain reaction takes place, but it will produce a large amount of energy in the form of heat, in the form of pressure, in the form of temperature, produced within a second. That means within a fraction of second. So this kind of chain reactions is nothing but uncontrolled chain reaction. This chain reaction is used in atom bomb to produce an explosion. Okay, so in atom bomb, what is the chain reactions, uncontrolled chain reactions. So we can't control the chain reaction, right? But if you go to the nuclear reactor, yes, the chain reaction controlled. Okay, that is the main difference between the controlled chain reaction and the uncontrolled chain reactions. Okay, right. You see this uncontrolled chain reaction. I'll tell you first one. See this uranium 235. Yes, and bombarded with one neutron. See, this is a one neutron. So what does process take place? Yes, it will be split up into barium and krypton. And see this neutron 1 and 2. Okay, and this one neutron again bombarded with uranium, it will produce again. See this 2. See again this neutron bombarded with uranium, again it will produce 2 neutrons. So this is first generation. This is the first generation neutrons. And if you go to this side, second generation neutron. And this is the second neutron generation. Again these two is, this one is bombarded with uranium again to produce 2 neutrons. And this one bombarded with the uranium again 2. Again this one bombarded with uranium again 2 neutrons, and again also. So this is the third neutron generation. So this process takes place continuously. It will produce that large amount of energy released. Okay students, and see this you will understand. I'll tell you now the three neutrons produced. That's why see this. An uncontrolled chain reaction can result in a violent nuclear explosion. So nuclear bombs are created using this concept. Nuclear bombs are created using this uncontrolled chain reactions. See this again. Uranium is bombarded with neutron. Okay, bombarded with what? One neutron will produce the barium, and krypton will produce the three neutrons, 1, 2 and 3. Yes, so again this neutron is bombarded with uranium 235 again to produce 3 neutrons. Okay, see this, so 3. So totally how many? 9 neutrons here. 3 plus 3, 6 and 3. So totally what? 9 neutrons. So again this 9 neutrons again is bombarded with uranium to produce another 9. So total. So 9 and 9 is the process will be continuously going on. That means the number of neutrons will be multiplying. So this is what? Uncontrolled chain reaction. Uncontrolled chain reaction. Okay students, right. Now and go to the next one, critical mass. Okay, what is critical mass? See this, during a nuclear fission process, about 2 to 3 neutrons are released. 2 to 3 neutrons are released. Yes, I shown no that progress. So 2 to 3 neutrons are released. But all 3 neutrons, these 3 neutrons may not be available to produce further fission reaction. So further which reaction? Fission reaction. So some of them may escape from the system. So 3 neutrons available now. So any one escaped from that system. So which is termed as leakage of neutrons. So that escape is nothing but leakage of neutrons, and some may be absorbed by the non-fissionable material present in the system. So 3 neutrons available, maybe 1 will be escaped and 2 will be remaining. So that 2 neutrons are absorbed by non-fissionable material. Okay, so these two factors lead to the loss of neutron. Okay, to sustain the chain reaction, the rate of production of neutrons, due to the nuclear fission and must be more than the rate of its loss. That means this can be achieved only when the size of fissionable material is equal to the certain optimum value, that is some constant value. So that value or that mass is nothing but critical mass. That mass is nothing but critical mass. Okay, yes, see this, the exact is critical mass definition. The minimum mass of a fissile material necessary to sustain the chain reaction is called critical mass. So actually this is the definition of the critical mass, so please note it down. Okay students, again I'm telling, the minimum mass of a fissile material necessary to sustain the chain reaction is called critical mass, mc. So this critical mass, it depends on the nature and density and the size of the fissile material. Fissile material means core material. Okay students, right, if the mass of the fissile material, mass of the fissile material less than the critical mass, and it is termed as subcritical. So if you are taking that any core material that mass is lesser than the critical mass, we called that material is subcritical. So if the mass of the fissile material is more than critical mass, that is termed supercritical. The mass of the core material is greater than the critical mass level, so that core under subcritical position, that means we called subcritical, sorry, supercritical. So if it is mass is less than the critical mass, we can called subcritical. Suppose the mass of the core material more than the critical mass, we can called supercritical. Okay students, in supercritical we can't create, we can't control, but in subcritical we can control that reaction rate. Okay students, right, atom bomb. See the atom bomb. The atom bomb is based on the principle of uncontrolled chain reaction. Already I said no, nuclear bombs are based on uncontrolled chain reaction. The same here, the atom bomb is based on the principle of uncontrolled chain reaction. So atom bomb principle is uncontrolled chain reaction. Okay students, right, and in an uncontrolled chain reaction, the number of neutrons and the number of fission reactions multiply almost in a geometrical progression. So this release a huge amount of energy in a very small time of interval and leads to explosion. That means so this atom bomb to produce a large amount of energy within a second. Yes, within a second we will produce a large amount of energy. That energy may be heat, temperature and pressure. Okay, now see the structure, then only you'll understand. See the structure. Atom bomb consists of piece of a fissile material. Fissile material means core material whose mass is subcritical. Their mass is what? Subcritical. And this piece has a cylindrical void. Yes, that means cylindrical place. That means the core material placed in cylindrical void. It has cylindrical fissile material which can fit into a void, and its mass also subcritical. So void material is subcritical. So when the bomb has to be exploded, this cylinder is injected into void using a conversional exploder. Yes, and now the two pieces of fissile material join to form the supercritical mass, and which leads to an explosion. Now I'll show you that. Yes, this one. See, this is the two voids, uranium 230 and 230. This is the two void, and this is the what that a part of the piece of cylindrical void. Okay, this is the piece, so this is that piece, uranium. Chemical substance explained by remote controlled method. So this is the uranium, that moving cylinder. When this moving cylinder is injected with the help of the control remote control system, this void is injected is to the this one. After that, the mass, that means the material under supercritical, then only it start to explosion. Before that, these the mass is less than the critical mass, so it is a that time the supercritical, sorry, subcritical position. Before explosion, the mass is lesser than critical mass, therefore we called supercritical, subcritical position. But when this void injected is into this one, now that time the mass is greater than critical mass, therefore that time the fissile material to be supercritical, therefore it start to explosion. Start to what? Explosion. So it's like a fuse, it's like a what? Fuse. So this one is injected with help of remote system. Help of what? Remote system. Okay students, then only to create the explosion. And during this explosion, tremendous amount of energy in the form of heat and light and radiations is released. Okay, and a region of very high temperature and pressure is formed in the fraction of second, along with the emission of hazardous radiation like gamma rays, because gamma rays very, yes, higher radiation, no, and high penetrating power also. Okay, therefore it will produce a hazardous radiation like gamma rays, so which adversely affect in living creatures. And this type of bombs, atom bomb, are exploded in 1945 at Hiroshima and Nagasaki in Japan during the World War II. Yes, so this type of explosion used in World War, yes, and that effect to be continued still now. Yes or no students, because that type of radiation to create that genetic diseases created. Yes or no students, right? So atom bomb is example for uncontrolled chain reactions. Okay, so we can't control, it will produce a large amount of energy within a fraction of second. Okay students, right? And do you know, so because this is 1 mark, electron volt is the unit used in nuclear physics to measure the energy of small particles, right? And it is nothing but the energy of one electron when it is accelerated using an electric potential of 1 volt. So please note it down. 1 electron volt value is equal to 1.602 into 10 power minus 19 joule. So 1 electron value is equal to 1.602 into 10 power minus 19 joule. And 1 million electron volt, that is 1 MeV, which is nothing but 10 power 6 electron volt. M means mega electron volt. Okay, mega means 10 power 6 electron volt. And the energy released in a nuclear fission process is about 200 mega electron volt. So in atom bombs, more than 200 is mega electron volt. Okay, so atom bomb is the example for nuclear fission process. Nuclear fission. Okay students, okay, right. Okay students, today class is over. We'll see on next class. Okay, we'll discuss the nuclear fusion process in next class. Okay students, Before that, just you have to go through the today's topic. Okay, students? Okay. Thank you, students.